Horizontal range.
Write it. Okay, horizontal range. The maximum distance covered by a projectile along the horizontal. Along the horizontal. Along the horizontal. Range, horizontal range will represent with a capital R. What is the representation? Horizontal range will represent with a capital R. Write it. What is the definition? It is the maximum distance covered by a projectile. It is the maximum distance covered by a projectile along the horizontal. Along the what? Horizontal. Here, along the horizontal. Okay, Barry? Everybody,
Yes,
now along the horizontal. Now, this range is, what is range in the picture? Represent here. Let me take this point is O and this point is A. Then OA is called as what? Everybody.
Horizontal.
OA is called as range. R is to called as horizontal range. Purema? Understood?
yes, sir.
Yeah.
Yes, sir.
Second point. This horizontal range depend on something. Can you tell me what is that? Everybody, very important here. Here.
Theta.
Theta. For example, sir, how, sir? Let us see. Now, all of you observe very carefully. One boy has been made a theta. Let me take, for example, 30 degrees. Example, I'm saying. So the body will take the projections and will goes like this and will fall. Another boy makes with the 60 degrees initial velocity. What is that, everybody? How much? 60 degrees. Then you can see some other XY thing. Then the body will goes and will takes and will fall somewhere here, or maybe it will goes up. So have you noticed that the range which is covered in different cases, different angle, that range is not equal? Am I right or wrong? Everybody?
Yes, sir.
Yes. So the range depends on the what? Angle of projection. So this theta only, the initial velocity, what the theta it is making with the horizontal is only called as angle of projection. What is to call?
Angle of projection.
Angle of projection. So range is depends on what? Range depends on angle of
Projection.
projection. That is what you have to remember. Okay, Princey, Gokul Raj, response Mari Darshan also. So angle of projection.
Yes,
Right, the second point. Range depends on the angle of projection. Range depends on the angle of projection. Range depends on the angle of projection. Is it okay, guys?
Yes, sir.
Yeah. Now,
Yes, sir.
one more interesting thing I'll say. For example, let me consider Mr. Mari and as well as Mr. Darshan, both are projected with the same velocity. All of you observe. Both are projected with the what? Initial velocity is what? Both cases initial velocity is what? Same. Yeah. And theta is different. This is theta 1, this is theta 2. Let me consider. Then both the cases, the horizontal range, maybe vertical point is different, but horizontal range is what? Same. Okay. So if the two bodies are projected with a different angle of projection, but what is equal?
Same velocity.
Same initial velocity. Same initial velocity. Then both bodies will cover with what? Everybody. They'll cover with the
Same distance.
same horizontal range. That is what you should understand. Agalya, Puriyama, Agalya, Alfin.
Yes, sir.
Yes. That is what you have to remember. It will depends on theta also, and also it will depends on what? Initial velocity. Now, third point. We all knows that in a normal thing, if I throw the ball like this, it will go like this and it will come like this. Totally we used to call something. What is that called as? Physics, we already studied. This fully we used to call something. Time of
Flight.
Yes. Time of flight. Correct? So time of flight means the time to reach maximum height. We used to call something. What is that? Time of ascent.
Ascent.
And the
Ascent.
time to come back, what is to call?
Time of
Time
descent.
of
Time of descent.
descent.
Time of descent.
And we all knows that time of ascent must be equals to what? Time of
Time
ascent
of descent.
must be equals to what? Everybody.
Time of descent.
Descent. Time of descent. Yes or no, everyone? Please respond. Same way, when I make the projectile motion, it reaches the maximum height here. So whatever the time it will take to reach the maximum height, from there, the same time it will take to come down also. Do you all understand? The time taken to reach the maximum height, for example, if I consider t seconds, time taken to reach the maximum height is t seconds. Then to maximum height to fall down also, it will take how many seconds? Everybody?
T seconds.
T seconds. So here also time is equal. Do you all understand, everyone? Clear? Yes, that is only the point. Okay, so that point is this one. So the time taken by the projectile to reach the highest point from the point of projection. Highest point from the point of projection. See, what is the point of projection? This is the point of projection and this is the highest point. So time taken by the projectile to reach the highest point from the point of projection is equals to time taken by the projectile to reach the ground. To reach the ground, again from where, guys? Again from?
Highest
Again
point.
from the what point? What point? Highest point. Understanding? From the point of projections to highest point to the ground. Always time is equals to what? Everybody. Yes, please.
Highest point.
Time is equals to equal. That is only the fourth point. I hope you all understand. Anybody having any doubt, you can ask. Clear, guys? All of you? So, for this projectile motion, we will use all the 4 equations of motions, which we already studied, which are applicable to the bodies that move along the straight path with uniform acceleration. So, if you notice it, all the 4 equations what we have studied is actually the horizontal motion and they are moving in a straight line. But in case of projectile, their motion is it a motion is a straight line? That is what my question. Is it motion is a straight line?
No, sir.
No. Then, is it possible to use the equations of motion? Is it possible to use the equations of motion? That is what my question. Everybody. See, we have 4 equations of motion. Tell me, what is the 4 equations of motion? Let me know. All of you fastly. V is equals to
ut plus half
U plus AT.
So U plus
Second is equals to, everybody
Yes,
don't know.
UT plus half AT square.
AT square. Third one. V square is
Yes,
equals
yes.
to
Square minus U square is equal to 2AS.
2AS. Fourth one.
equal to ut
Yeah.
plus half
Wait a
x
second.
minus
Sn is
minus
equals to.
x
Sn is equals to fastly. U plus.
Sn is equal to u plus a by 2
A by 2
2n
into
minus 1.
2n minus 1. Am I right?
Yes, sir.
Yes or no? Or we can say A into, or we can say U plus A into n by 2 minus 1. Am I right? N by 2, sorry, n minus 1 by 2. Correct? Everybody?
Yes, sir.
This is wrong. Not n by 2. What is that? N minus 1 by 2. Clear? So these are all the 4 equations. When it is possible to use, we cannot use directly for the projectile motion because these all the 4 equations are what? They are applicable to the bodies that move along a what? Straight path with
Straight line.
uniform acceleration. Straight path. These are applicable. Please write it. These are applicable only moves along straight path. Moves along the straight path with what acceleration? With the uniform acceleration. Okay.
Acceleration.
Understanding either vertically downwards or horizontally like this. Either this motion or this motion we can apply it. Working under gravity we can. Yes or no, guys? We have studied or not working under gravity? Yes or no? But projectile motion, it is not a straight line because it is a curved path, parabola. Then, is it possible to apply these equations directly? Everybody?
No, sir.
No, we people cannot apply. Then, sir, what to do it? That is what we are going to study. So keep it in mind. If theta is the angle of projection, shall we complete that also so that we can solve tomorrow numericals? Any problem for anybody?
No, sir.
Yes, please. Respond, Ra.
No, sir.
So, sir, we cannot use the equations directly because these are applicable to only what, guys? Only for straight line. Clear? Now, what is the modification we have to do it? So as we know, we have been projected with the initial velocity. What is the initial velocity? Everybody, u with the theta angle. What is the theta? What is the angle? Angle of projection. What is the angle of projection? Angle of projection means what, guys? Theta only. Am I right or wrong? Yes. Then
Yes, sir.
you have to take as it is two-dimensional motion. It is a one single dimensional, two-dimensional, 2D motion.
Two-dimensional.
Now, Agalya, observe very carefully. Shivani, you also. Now, this is what is the projectile motion with the body's initial velocity u and it is making the angle of projection theta. Then, x-axis the velocity is, see, I projected with initial velocity u. Then x-axis the velocity is u cos theta and y-axis the velocity is u sin theta. Y-axis, what is the velocity? Everybody? U sin theta.
Sir, what is between cos theta and sin
Cos
theta?
theta
Sir?
and sin theta trigonometry functions, mathematics. Okay, I will teach you. Understand, Mari? They are sin theta and cos theta mathematics functions. Okay, va? Angle. Clear? Trigonometry. Trigonometry will study that. Okay, Mari?
Yes, sir.
So in projectile motion, you cannot take the initial velocity u. You have to take x-axis, initial velocity is u cos theta, and y-axis, what is the initial velocity? U
Sin theta.
sin theta. For example, listen very carefully. If suppose theta is given here, then all of you observe, wherever theta will comes, that will become u cos theta, and the opposite one will become what? U sin theta. Clear? So suppose here is the theta, all of you observe, here is the theta, then here what will come? Here will come u cos theta.
Cos
And
theta.
here what will come? U sin
U
theta.
sin theta.
Okay, that is what. Now, sir, how to use these formulas? Let us modify the formulas. So we all knows that a projectile after certain interval of time, we need to know its horizontal and vertical displacement. So if the projectile motion is taking place, for example, like this, it is taking place. Suppose I want to know at this point, what is the horizontal velocity and I need to know vertical velocity. Am I right or wrong? Because it's a two-dimensional. Right or wrong, everybody?
Yes, sir.
Yes, please.
Yes,
So
sir.
at any point, at this point or at this point, whole journey, at this point, any point, I want to know horizontal component and vertical component. So what is the horizontal component? U cos theta, and vertical component is what? Everybody? U sin theta.
U sin theta.
That is what. So it is necessary to just
Sir, U is
modify.
initial velocity, yes, sir.
Yes, Mari. U is the initial velocity, which is projected body. Clear? Okay.
Yes, sir.
Then it has a two-dimensional because it is a two-dimensional motion. So if theta is the angle of projection with the initial velocity u, then the horizontal component of velocity is what? Horizontal component of the velocity is what? U cos theta, and vertical component is what? Everybody? U
U sin theta.
U sin theta. Then there is no kind of no change in the horizontal component of the velocity of the projectile, because horizontal motion always acceleration is a what? I already told you. Horizontal motion acceleration is what? Everybody?
Zero.
Zero. All of you should remember that. In acceleration in horizontal direction is what? Everybody?
0.
Zero. Okay, ma. U cos theta, U sin theta, it is actually two-dimensional motion. As the body is projected with the U, but velocity is acting in two different directions. Understand, Lakshanya?
Yes, sir.
That velocity in y direction, it is actually U sin theta. It is a trigonometric functions. And velocity in x component, it is the U cos theta. Okay, va?
Okay, sir.
Yeah, we all knows that if the body is in projectile motion, I already taught you. What is that the x-axis? What is the acceleration? X component. Acceleration is what? Every point. Acceleration is what, Ra?
Zero.
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 Because body will move with what? Uniform
Constant velocity.
Maximum motion.
uniform velocity or constant velocity. So only the body is having one thing. What is that? Vertical acceleration. Yes or no? Because of influence of what? Influence
Gravity.
of gravity.
Gravity.
Understanding? That is you should remember. So if you all notice it very carefully, here the formulas can be modified. For example, they will ask you, let me take the horizontal and the vertical displacement can be obtained by using the second equation. So second equation, what is the second equation? Anybody can tell me? What is the second equation?
S is equal to UT plus
S is
half
equal
AT
to
square.
UT plus half AT square. Now, I want to find horizontal range, understanding, and vertical range, maximum. Vertical range, vertical displacement and horizontal displacement. Both I want it. I want horizontal and vertical displacement. So how to obtain it? Very simple. So if you notice it, S is equals to UT plus half AT square. As we all knows that X direction, gravity is what? Acceleration is what? Everybody. X direction, Y component, and this is X component. X component, somebody is 0. G is equals to what? Everybody.
Zero.
Zero. Acceleration is 0. So that equation will modify. Displacement in X direction. That is what? Which is equals to range. What range it is? Horizontal.
UT plus half T square.
Horizontal range. UT illamari. U is a what?
UT.
Why? My U is equals to what, amma? X axis. U cos theta. U
Initial
cos
velocity.
theta into T plus half into G value. G value is 0. So 0 into anything. What is that?
Zero.
0 only.
Zero.
So horizontal range, what is the formula? U cos theta into T. Okay, physics you will get it. Second chapter I will teach you. When we are studying work and energy, you will get it this cos theta and all. Cos theta is a trigonometry. So what is the formula for horizontal range? Everybody, U cos theta into T. Okay, then what about the Y component? Displacement in Y component. What is the formula? U sin theta into T. Understanding? Everybody, please respond, Ra.
Sir, in this case, S is equal to what, sir?
S is equals to displacement, horizontal range or vertical range. Clear? Ra?
Same displacement, sir.
Yes, Mari?
Yes, sir.
Understood, Rama? Everybody?
Yes, sir.
Yeah. So next,
Yes, sir.
if you notice it, Y component body is going like this and coming like this. So always you can see acceleration, body is accelerated motion. Do you all understand, everybody? Clear? So now I am giving the formula directly, but you are going to derive in our class 11th. What is the formula? How the formula is coming? So what is the Y component formula? Y component, what is the velocity? X component, we know that U cos theta. And what is the Y component formula? U sin theta. So U sin theta into T minus half GT square. So this is the formula for finding the horizontal range and vertical range. This is for horizontal range and this is the vertical range. If you want to find, all of you listen, at any place, suppose this is the projectile motion. What is this maximum height at this point? And what is the maximum displacement, horizontal range? At this point, what is the displacement? What is the horizontal range? At this point, horizontal range and vertical range, if you want to find, you can use this one and you can calculate it. So that is how the projectile motion, we cannot use the equations of motion directly. So we have to use the components, x-axis and y-axis, and you have to change it. So always remember, if a body is projected with some angle of projection with a theta, then with the initial velocity u, so here x-axis, what will happen? This will become u cos theta, and here what will happen? U sin theta. Wherever theta will comes, that is opposite one is x u cos theta, and other one is u sin theta. That is what you have to remember. So this is how we have to modify the equations, projectile motion, normal equations from the uniform acceleration, we have to modify to the horizontal, like projectile motion with the 2 dimensions. That is why it is called as 2-dimensional motion. What is to call, everybody? We used to say 2-dimensional motion, 2D. X-axis also velocity is there and y-axis also there. But only acceleration is acting in what direction? Projectile motion. Only accelerating motion in
Vertical direction.
accelerated motion in vertical range only. No horizontal one. At any point, horizontal velocity is what? Constant. So that acceleration in x-axis is what? Everywhere.
0.
X-axis is 0. Only it has uniform velocity or constant velocity. Velocity in x-axis is remains what? It is not 0. It remains constant. Okay. So that is what you have to remember. So a projectile motion means body should fall under the what? Body should fall under the what? Gravity.
Gravity.
Okay, that is what you have to remember. So this is what is projectile motion and horizontal range. Now the worksheet what I given, in this you can find the questions calculating the horizontal range and vertical range. You can use these formulas and you can try it. Okay, then now after this I will send you some 3 pages. Take that print. What is that print I said? What is the use of that print? Everybody, it is for graphical representation of motion along a straight line. Now immediately after the class I will send you. Take that print and each one you should read, and tomorrow you should give me the feedback. Yes sir, we are completely understand. This particular point I am not understanding. Then if you say me, I will explain that particular one. Do you all understand, everybody? Clear? So that is what about the today's class. I hope you all liked it. Is it okay? Do you all feeling something new? Everybody?
Yes, sir.
Yes,
So
sir.
thank you. Those who joined late, you can watch the video and you can learn. We'll meet in tomorrow's class. Thank you, all of you.